Hello students, today we are going to discuss a very important basic concept of acids and bases. Already you have read in junior classes regarding acids and base and salts, but today that we will discuss this some higher concept, some better clear-cut idea about the acids and bases. That the concept that you have read in junior classes, it remains same, but some more knowledge regarding acids and bases we will discuss today. So, concept of acids and bases, before discussing, I want to tell you regarding the idea about the electrolytes. What are electrolytes? Electrolyte, the substance which can conduct electricity in aqueous medium or in molten state. The substance which conduct electricity either in aqueous medium or in molten state are called electrolytes. Electrolytes is a conductor, good conductor we can say, and metallic conductor also, it is a substance which conduct electricity, but the difference between electrolytes and metallic conductor is, in metallic conductor has free electrons. Due to availability of free electrons it conduct electricity. But in electrolytes, availability of free ions. When ions will be free, then it can move due to movement of ions, electricity, that is the charge, that flow, that is called current. So, the electrolytes, the substance which conduct electricity is called electrolytes in aqueous medium. So, on the basis of electrolytes, may be two types. That electrolytes is of two types. One is weak, second one is strong. That means weak electrolytes and strong electrolytes. Weak electrolytes means, already you have read, that is in junior classes, weak means the dissociation is slow. That means when the substance dissolved in water, it produces ions. If it produces ions, the weak means the dissociation is very slow, and strong means the dissociation is very high. That means weak means that is slow dissociation, and strong means that dissociated fastly, This is the difference between weak electrolyte and strong electrolytes. Strong electrolyte slowly dissociated, and strong, that is weak electrolyte slowly dissociated, and strong electrolyte highly dissociated. This is the difference between strong electrolyte and weak electrolytes. Already you know that is weak means weak acids, and strong means your strong acids. These are the strong electrolytes and weak electrolytes. When the substance, suppose it is the electrolyte, when it dissociates in water, it produces corresponding ions. It produces, let it be A plus and B minus, it produces. And these in water, when dissolved in water, it produces A plus aqueous and B minus aqueous. So this is the first important features, a characteristic of electrolytes. All electrolytes dissociates in water, forming oppositely charged ions. This formation of opposite charged ions results the conduction of the electric current. So, this when it dissociates, if dissociated weakly, if dissociated fastly, there will be difference. If let AB is on weak electrolyte, is an weak electrolyte. AB is an weak electrolyte means when it dissociates, it produces cation and anion. But as is weak means dissociation is not complete. Some undissociated particles of reactant remain in the solution. So AB will not completely dissociate. So if it is not completely dissociated, already you have read in equilibrium, characteristic equilibrium, when the reactant will be remain or some unreacted mass remains, undissociated mass remains, so there will be equilibrium between dissociated and undissociated. So what happens? There is equilibrium between dissociated part and undissociated part. So it exists in equilibrium. But if it is completely dissociated, then no mass will be left. The reactant mass will be 0. After the reaction, completion reaction, we can say the mass of reactant will be 0 because almost all reactant convert to product. So there will be no equilibrium. So for the weak electrolyte, always equilibrium is maintained between undissociated, this is undissociated, and dissociated ions. So dissociated ions and undissociated, there will be equilibrium. But in case of strong electrolyte, what happens? This is an example of strong electrolyte. If it is a strong electrolyte, almost all reactant will be converted to product. Or all reactant will be dissociated into corresponding ions. So nothing will be left, so that equilibrium cannot be achieved. For weak electrolyte, always it exists in ionic equilibrium between the undissociated particles, and this is called ionic equilibrium. There is ionic equilibrium between undissociated particles and ions produced. Okay, so this is the concept of electrolytes. Then what are the definition of acids and bases? We will just define in this concept using ionic equilibrium concept. What are the acids? The acids, the concept, first concept is, that is Arrhenius concept. Arrhenius concept. Arrhenius concept. The concept shows that, they indicate that for the substance is acid, that acid is a H plus donor. Acid is an H plus donor. This is the first definition. Acid is an H plus donor in aqueous medium. And the base is a OH minus donor in aqueous medium. This is the main definition of acids and bases by Arrhenius concept. According to Arrhenius, if the substance produces H plus ion is called an acid. If the substance produces OH minus in water, that is called base. This is the type. For example, HCl is an acid in water produce H plus ion and Cl minus ion. But generally, this H plus ion cannot be free in water. It combined with water produce hydronium ion. Generally, acids produce this is called hydronium ion. The substance which produces hydronium ion in water is called acid, or to produce H plus ion in water is called also acid. Both are called hydronium ion because H plus will not be free in water. It combined with water, it will produce hydronium ion. So Acid is a H plus donor and OH minus. Suppose example sodium hydroxide in water produce Na plus and OH minus. So base is a OH minus donor and acid is what? H plus donor. So this is the what? Definition of Arrhenius concept of acids and bases. So some acids are very strong, some acids also some acids are weak, some acids are strong on the basis of their electrical conductivity or the dissociation nature. If highly dissociated, that we are called strong. What are the strong acids? Strong acids and bases. If you write both HCl, sulfuric acid, nitric acid, these are called what? Strong acids. And strong acids and base also NaOH, KOH, these are called strong acids and base. Weak acids and bases. Weak acids means your carbonic acids, acetic acids, ammonium hydroxides, calcium hydroxides, aluminium hydroxides. These are weak acids and weak base. These are also very important. What are the strong acids? What are the weak acids and bases? Here the dissociation is very fast. Here dissociation is slow. Weakly dissociated, it is fastly dissociated. This is the difference between strong acids and bases. Then this is Arrhenius concept. Then second concept that we will discuss now, these are called that Lowry and Bronsted concept. Lowry and Bronsted concept. What is Lowry and Bronsted concept? Lowry and Bronsted concept is like this. Acids are H plus donor, okay, and bases are H plus acceptor. This is the difference. Very important, these things. So H plus donor are called acids and H plus acceptor are called base. But here there is no the concept of OH minus. There is no concept of OH minus. But here the concept is taking H plus ion. If the substance producing H plus ion or donating or releasing H plus ion, these are called acids. If the substance is accepting H plus ion, these are called base. This is called Bronsted base or Lowry base, you can tell. Anyone you can tell. But this, if one is H plus producing H plus ion, other is accepting H plus ion. So only the difference you can say, both are conjugate to each other. Both are conjugate to each other and differing H plus ion. Very important. The conjugate acid and base, the electron donor, H plus donor and H plus acceptor, only difference is H plus ion. And another concept is like this: for strong acid has weak conjugate base. Weak conjugate base and vice versa. And vice versa. That means, what does it mean? If acid is strong, its conjugate base is weak. If base is strong, its conjugate acid is weak. So both are what? Conjugate to each other, and one will be strong means other will be weak. And they differ in number of H plus ion. Only one H plus they differ. Example, For example, suppose H plus, HCl. HCl in water, already we discussed, it produces hydronium ion and Cl minus. Because H plus produced will be accepted by water and forming hydronium ion. So it is a H plus donor like this. So as it is donating H plus to water, so it is called acids. As H plus is accepted by water, so it is a base. But you see, after losing H plus ion, the substance produced can accept again H plus ion. It can accept H plus ion. It is losing H plus ion. The substance produced, this is called conjugate base. And water, as it is accepting H plus, so after accepting H plus, the substance produced is called conjugate acid. So this is very important. HCl is conjugate base is Cl minus, because after losing H plus ion, water is accepting H plus, that's why it is a base and the substance produces conjugate acid. So after losing H plus and after losing or accepting H plus ion, the substance produced will be conjugate to the what? The substance from which it is produced. HCl, as it is losing H plus ion, so it is acid. Its conjugate base is, after losing H plus ion, it will be conjugate base. So acid and conjugate base, or conjugate acid and conjugate base, they differ in H plus ion. This is very important. Both are conjugate to each other and differ in H plus ion. Okay, so HCl is an acid, its conjugate base is Cl minus. Water is a base because accepting H plus, so it is a base and its conjugate acid is H3O plus. So this is very important distinction, very important identification of conjugate acid and base. Just you add H plus ion, the substance produced will be conjugate acid. If you remove H plus ion, that is conjugate base. So this is the difference. Okay, so let us example other examples. Suppose NH3. If you add H plus ion, it is produced NH4 plus. So as it is accepting H plus, so it is a conjugate base. As it is accepting and the substance produced will be conjugate acid. As H plus is accepted by ammonia, so it is a conjugate base and the substance produced will be conjugate acid. When you write the conjugate acid of any substance, just to add H plus ion. If you want to write the conjugate base, suppose ammonia, when you lose H plus ion, then you produce NH2 minus. As losing H plus ion, so it is a conjugate acid. And after losing H plus ion, the substance produces conjugate base. So when conjugate base you want to derive, you remove H plus ion. If you want to produce conjugate acid, you add H plus ion. This is the difference between conjugate acid and conjugate base. For example, sulfuric acid, it has HSO4 minus. That means after losing H plus, it is conjugate acid. It is called conjugate base. Water has OH minus. That means after losing H plus from water, it OH minus produced. So it is called conjugate acid. Because losing H plus donor, it can accept OH minus. This is conjugate base. Just minus H plus. Minus H plus. After losing H plus, conjugate base. After losing H plus, conjugate base. Okay, so these are very important. That concept of conjugate acid and conjugate base after loss of H plus or after addition of H plus. If you add H plus, the substance produced, that is conjugate acid. If you remove H plus, the substance produced, that is conjugate base. So conjugate acid and conjugate base differ in H plus ion, and for strong acid the conjugate base is weak. If our sulfur is strong, it is strong. If it is strong, you write here it is strong, so it is weak. This conjugate base is weak, but conjugate acid is strong. Always one is strong means next other part is weak. So this is the concept of what? Arrhenius concept and Glory and Bronsted concept of acids and bases. Next we will discuss that Lewis concept. Okay, you write this one, you complete this one. Okay, let me erase this, you complete it. Next concept of acid and base is Lewis concept. Lewis concept, this is somewhat different compared to your Arrhenius concept and Bronsted concept. Here, in terms of electron transfer, already we have discussed H plus donor, OH minus donor, H plus acceptor in this concept, already we have discussed. But here in terms of electron, Lewis concept tells that electron lone pair donor. Electron lone pair donor are called acids, are called bases, What are the base? According to Lewis concept, electron pair donor are called bases, and electron pair acceptor are called acids. That means electron donor are called base, electron acceptor are called acids. That is in concept of electron transfer. If electron is donating, that is base, electron accepting, that is acids. But which type of substance can donate electron which has availability of lone pair? For example, bases, that Lewis base. Lewis base may be a neutral substance having lone pair. For example, ammonia is a Lewis base because having nitrogen having lone pair, water having lone pair on oxygen, alcohol having lone pair on oxygen. So like this, these are electron donor because availability of lone pair on its central atom. That's why these are called what? These are called electron donor or Lewis base. And some already having negative charge, Cl minus, OH minus, Cl minus, these are the having negative charge means already it has lone pair on the atom, extra electron on the atom. Therefore, these are also called Lewis base, having lone pair on the atom. Then Lewis acid. Lewis acid means electron for acceptor. Acceptor means having vacant orbital. BF3, boron has vacant p orbitals like this. Then BCl3, then FeCl3, AlCl3, all having vacant orbitals. Aluminium having vacant orbitals. Iron having vacant orbitals. Here vacant d orbitals. Here also vacant d orbital available. Boron vacant p orbital available. So these are called Lewis acid. In the formula you cannot know, but if you see the structure, how many electrons, bonded electrons, how many unpaired electrons, how many vacant orbital available, you can know from the bonding. So boron, as boron has what? 2p, boron has 2p1 configuration. 2p1 means 1s2, 2s2, 2p1. As 2s2, 2p1 means 2p. P is vacant. Here same, iron, D is vacant, aluminium, P vacant and D both vacant. So that's why these are called Lewis acids. And other type is having positive charge. H plus is a electron lone pair acceptor, and Cl plus, that is the accept any plus charge. H plus, Cl plus. Okay, NO2 plus. So these are called Lewis acid because having positive charge means having vacant orbitals. So other types of Lewis acids and bases, that these are having pi electron, multiple bond. Molecule having multiple bond will be a Lewis acids. For example, carbon dioxide, Lewis acid, your carbon monoxides, and your sulfur dioxides. These are acts as what? Electron acceptor. They accept electron because due to how they accept electron, just I will show you here. If as oxygen carry more electronegative, so they takes electron, this pi electron that shifted towards oxygen, so that carbon become positive charge. As carbon become, when the oxygen taking the pi electron towards itself, so carbon become electron deficient. When carbon electron deficient, so it can accept lone pair from the others. That's why multiple compound having multiple bond can act as Lewis acid. These are the Lewis acid, these are the Lewis base. Mainly having negative charge, almost all are called Lewis base. Having lone pair, if you count the lone pair on the central atom, you can know who are Lewis base, who are Lewis acids. So these are some concept of what? Acids, that Arrhenius concept, Lowry and Brewster concept, and is Lewis concept. Let us take one example that who are Lewis acid, who will be the Lewis acid. For examples, reaction between BF3 plus ammonia. If you see, already we have read that coordinate covalent bond, that is dirty bond. We know nitrogen having lone pair, but boron having vacant p orbitals. So what happens? It can donate electron to the boron. So that will be what? You can write similarly H plus ion when combined with ammonia forming ammonium ion. Here what happens? H plus ion having vacant orbitals, nitrogen having lone pair, it can donate and forming ammonia. So it is, as is electron acceptor, so it is Lewis acid. As is electron donor, this is a Lewis base and forming ammonium ion. So this is the concept of Lewis and acid, Lewis acid and base. Then we will discuss some examples of conjugate acid and base. So this side is conjugate acid, this side is conjugate base. For example, you take HSO4 minus, and water, then ammonia, then CO3 2 minus, and HSO4 SCO3 minus. Let us discuss what are the conjugate acid and base produced from this species. So HSO4 minus, conjugate acid means always you are H plus ion. When you add H plus ion, the substance produced is called conjugate acid. So you add HSO4 means H2SO4, as HSO4 become H2SO4 minus plus neutral. Then water is a neutral having two hydrogen. When H added become H3O. Then as neutral plus is added, it becomes plus. Ammonia neutral, H plus means NHO4 plus, already discussed these examples. Then CO3 2 minus, already carry 2 negative, H plus become HCO3, but as 2 minus plus 1 minus remains. HCO3 H plus become H2CO3, as plus minus become neutral. So this you take care of the charge. When H plus will be added, plus charge increases. When H plus will be removed, minus charge increases. So conjugate base, remove H plus ion, remove H plus ion, remove H plus ion, remove H plus ion, remove H plus ion. Here HSO4 minus, H is removed, that means remaining is SO4 minus, already it has 1 minus. When H plus is removing means minus will increase, 1 minus will increase, so become 2 minus. Water is neutral, it is losing H plus means OH, then minus charge. Here because it is neutral, H plus release means minus charge will be 1 minus charge increase. Ammonia NH2, after losing H become NH2, then neutral means minus. Here CO3 minus has a no hydrogen, as it has no hydrogen, conjugate base is not possible because it has no hydrogen. Similarly, as it has one hydrogen, result is CO3, and already 1 minus is there, then another minus will increase. So this is some examples of formation of conjugate acid and conjugate base from the particular substance, maybe ions, maybe neutral. So you have to practice in this way. Conjugate acid means H plus will be added, conjugate base means H minus will be removed. So then you have to take care of the charge. H plus is removing means minus charge will increase. Already 1 minus become 2 minus. Neutral, single minus. Neutral, single minus. Here it has no hydrogen, that's why conjugate base is not possible. Single minus, double minus. So you have to take care of this thing. Okay? You practice, any doubt, you can ask me. Okay? Thank you.